Good morning, students, and welcome to April. Spring is here, and we'll start today with our Do Now. We have a prompt I'd like you to respond to about starting new projects. Our objective today will be to begin factoring polynomials. We will identify and factor out the greatest common factor. Our essential question: how does knowing the greatest common factor help us to factor those polynomials? So our assignment will be to complete the Do Now, complete 2 pages, complete our exit ticket. If you're a distance learner, please remember to submit your work on Teams. And if you are in person, I will come around the room and I will see that you're working. For homework, I'd like you to complete homework 5, which is called Factoring Polynomials, Greatest Common Factor. That should be an F. Sorry about that. So important. We are now in the 4th quarter of our year. All quarter 3 work should be complete and turned in. Pay close attention, students, to the lessons for the next 2 weeks, as these are the lessons that will prepare us to solve quadratics. And I always tell you, to the extent that you can do this factoring, it will help you be very successful with quadratics when we get there. So we'll come back to our exit ticket in a minute, but first our Do Now. April's a good month to begin a new project. What is a project you'd like to start? Do you want to make something, learn something, or be something? People often think about January and September as the fresh start months, but I think spring is also a great fresh start month as well. So think about something you want to do, be, learn, or know more about, and maybe April is a great time to get started with that. So I'd love to hear what you're interested in. So please tell me right there. So let's talk about this factoring. So we're going to warm up by applying the distributive property to these 3 polynomials. So if we distribute a through the quantity of 3a plus 7, a times 3a is 3a squared. A times 7 is 7a, and we're adding those. Negative 2m times the quantity m squared plus 6m minus 1 becomes negative 2m to the 3rd power minus 12m squared plus 2m. And 4x to the 3rd power y multiplied by the quantity of x squared minus 2y becomes 4x to the 5th power y minus 8x to the 3rd power y squared. So now we're going to start talking about factoring. Factoring is separating a polynomial back into a product. And why would we want to do this? Well, this is going to help us as we get ready to solve quadratics. Now let's just review a few terms. When we multiply a product times a product. We multiply a factor times a factor. And we get the answer, which is called the product. Okay, so factor is a number that can be multiplied or a variable that can be multiplied with another factor in order to get a product. Okay, so that's how we're using those terms. If we divide the product by a factor, we will get the other factor, right? So if we were to take a product and divide it by one of the factors, so let's call this factor 1, factor 2. If we were to divide a product by factor 1, we would get factor 2. And if we were to divide a product by factor 2, we would get factor 1. Okay, so just a quick review on how we're using terms. Now, the simplest form of, let's say, for example, 4a squared plus 8a would be, we can't reduce that any further. Okay, we cannot combine a squared with a. They are not like terms. So that would be the simplest form of this particular expression. Well, if we want to factor that, we're looking for a number and a variable, or combination of number and variables that are common to both 4a squared and 8a. And then we say we pull those outside of the parentheses, and whatever cannot be factored is left inside the parentheses. So in this case, we can pull 4a out of each one of these terms. So we're going to have 4a on the outside, and then we were not able to factor out an additional a from the first term and an additional 2. Now remember, if we distribute 4a through a plus 2, 4a times a equals 4a squared, and 4a times 2 equals 8a. So we would end up back where we started. So that's how you can tell if you've done it correctly. Now, sometimes you cannot factor a polynomial, and polynomials that cannot be factored are called prime. So now we're going to do a bit of factoring. I'm going to show you a number of ways to factor over the next couple of weeks, but we're going to start with factoring a GCF, the greatest common factor. And the steps for factoring the greatest common factor are to, step 1, identify the greatest common factor of the polynomial. So first you check the coefficients, the number in front of the variable. Then you check the variables. And the variable must be present in all terms for it to be a greatest common factor. If it's present in all terms, take the variable with the smallest exponent. Okay, step 2, divide each term by the greatest common factor and leave the remaining factors inside the parentheses. And then step 3, you can check your work by distributing, and then you'll know that you've done it correctly. So let's get started with a few of these, and let's see how you do. We'll do the first few together first. So our directions ask us to factor each polynomial. We're going to check our work by distributing. If the polynomial cannot be factored, we will write prime. So 3x plus 12. Well, we cannot pull the x out because we do not have an x in the second term, but we can pull out 3, and that leaves x plus 4 inside the parentheses. Now, if we were to distribute that, we would be back at 3x plus 12, so our answer checks. So the factored form of 3x plus 12 is 3 times the quantity of x plus 4. So number 2. Now, students, be very careful of those invisible ones, and please be careful as you watch the signs, the subtraction in particular. So 7y minus 7, we're going to pull out the 7. So 7 times the quantity of y minus 7 divided by 7 is 1. Now, if we distribute this back, we would end up with 7y minus 7. So our answer checks. So the factored form of 7y minus 7 is 7 times the quantity of y minus 1. Number 3, let's see, we have 8m plus 36n. There's no variable that can come out. It must be present in both of the polynomials. But we can pull out a 4. So 8 divided by 4, or 8m divided by 4, is 2m. 36 divided by 4 is 9, and we have that n there. And that's our final factored form. If we distribute the 4 back through, we have 8m plus 36n. And number 4, 5x plus 30y. We cannot pull out a variable, but we can pull out the 5. So 5x divided by 5 is x, and 30 divided by 5 is 6, and we cannot pull out that y. So again, there is our final factored form. So try the next, try them all. And I will do them, but try them on your own and then come back and let's see how you do. Okay, so number 5, 6a squared plus 27. No variable can come out, but we can, 6 and 27 are both divisible by 3. So that would be 3 times the quantity of a squared plus 9. And number 6, we have a y present in both terms. Y squared in the first term, y to the first power in the second term. So we can only pull out one y. So we can pull 4y out of there. And 4y squared divided by y, 4y is y. 24y divided by 4y is 6 because we've pulled the y out. Now, how do we know that's correct? 4y times y is 4y squared. 4y, and then our negative sign in the middle, our minus. 4y times 6 is 24y. So number 7, we're going to take 3 and d. So 21 divided by 3 is 7. And we have that c minus 1. If you pull out the entire term, you have to put a 1 there. Number 8. So the largest common factor of 14gh and 18h is 2h. 14 divided by 2 is 7. GH divided by h is g. And 18 divided by 2 is 9. And we've already factored out the h, so this is our final answer. Number 9, 15a squared b minus 30ab. So we can take out a, b, and 30 and 15 are both divisible by 15. So 15ab comes out. And that leaves a minus 2. Number 10, 16bc squared plus 24bc. We can pull out 8bc, and 16 divided by 8 is 2. That leaves 1c plus 24 divided by 8 is 3. And we factored out the bc on that one. Number 11, ab minus a. A can come out. That leaves b minus 1. Okay, when we pull out the entire term, we have to hold that place with a 1. So number 12, x squared y plus 3xy. We can pull out x and y, which would leave x plus 3 because we've factored out the entire variable on that second term, 3xy. And number 15, now number 13, 5x minus 13y. There's no greatest common factor. That expression is prime. So number 14, 18x squared bc squared minus 48 abc to the third power. So 18 and 48 are divisible by 6. And we can pull out an a b, and a c squared. Okay, our smallest exponent is a 2. And that leaves 18 divided by 6 is 3. We've pulled out 1a, we've pulled out the b and c squared, so that leaves an a minus 48 divided by 6 is 8. And that just leaves a c, and that is our fully factored expression. Okay, number 15, 2x squared y minus 2xy squared plus 4xy. We can take a 2, an x, and a y out of there, which would leave us with, in the first term of this trinomial, x minus y plus 2, because xy was factored out. And number 16, 9r to the 8th power minus 18r squared s minus 24rs squared. Everything's got an r. We cannot take an s out, but we can. Everything is divisible by 3. That's the largest common factor. So we pull out 3, and we can pull out only one r, because our lowest exponent is a 1 right there. So 3r. So 9 divided by 3 is 3. And that leaves r7 minus 18 divided by 3 is 6. rs minus 24 divided by 3 is 8. R was factored out. We have that s squared. So as you work, I'm hoping that you are seeing how the exponent rules are working kind of in reverse, so to speak, here. Okay, you know that if we want to divide exponents, we subtract them. When we factored out r from r8, we had r7. When we factored out r from r squared, we had 1r. When we factored out r from r, there were no r's left in that 8s squared. So number 17, 6y to the 4th plus 14y to the 3rd minus 10y squared. We can factor out a 2 and a y squared, which would leave 6 divided by 2 is 3y to the 2nd plus 14 divided by 2 is 7, 1y, and that'll be an invisible exponent of 1, minus 10 divided by 2 is 5, and we have factored out the y squared. So that's correct and finished. So number 18, 12, a to the 5th, b to the 2nd, minus 36, a to the 4th, b to the 3rd, minus 6, a to the 2nd, b to the 2nd. So we can factor out certainly a 6, a squared, and a b squared. So 12 divided by 6 is 2. That leaves a to the 3rd, and the b's have been factored out. Minus 36 divided by 6 is 6. That leaves a squared and 1b, just b to the 1st power, minus, and we factored out the entire term, 6a squared b squared, so we'll put a 1 there. And that's number 18. So number 19, 14gh squared plus 28gh plus 14h. So it looks like we're factoring out the whole 14h. So we'll have a 1 at the end of this trinomial after it's factored. So 14gh squared divided by 14h leaves simply gh plus 2g plus that 1. And number 20, 18x squared yz minus 24x z squared plus 36 yz to the 3rd power. We cannot factor out a y because we don't have a y in the middle term, but we can factor out a z, and the greatest common factor of 18, 24, and 36 is 6. So we're going to factor out 6z. 18 divided by 6 is 3. We'll have x squared y minus 24 divided by 6 is 4. X and then z to the first power plus 36 divided by 6 is 6. Y z to the second power, and that's our final answer. Now, if you were to distribute every one of these that we're working on, we would end up with the original expression. So number 21, m to the third n minus m squared n squared plus 5m n to the third power. So it looks like we can factor out m to the first and n to the first. So m n. So that would leave m squared, because we factored out the n, minus m n plus 5n squared. And again, if you were to distribute the mn through these three terms in that trinomial, you would end up back where we started. And number 22, 16x y squared plus 28xy plus 8y. We can factor out from 16, 28, and 8, we can factor out a 4. We cannot factor out an x, but we can factor out a y. 16 divided by 4 is 4x, and we have y to the first power. 28 divided by 4, 7. We factored out the y, but the x is still there. Plus 8 divided by 4 is 2, and we factored out that y. All right, last two problems. Doing well today. Great job, students. We have 35a squared minus 20ab squared plus 15a. 35, 20, and 15, let's factor a 5 out of there, and we can factor out an a. 35 divided by 5, 7. We factored out 1a, that left 1. Minus 20 divided by 5, 4. We factored out the a, but we have the b squared there. 15 divided by 5 is 3, and we factored out the a. So our work is complete for number 23. And finally, number 24, 3a to the third b squared c minus 9a squared b to the third c squared plus 15a b to the fourth power c to the third power. So 3, 9, 15, let's factor out a 3. We can factor out a to the first power. We can factor b to the second power and c to the first power. So with the first term, we don't have to put a 1. 3 divided by 3 is 1, because we have a part of that term that will be our placeholder. We've got, I forgot to put my b squared there. We've got the a to the second power. So because we have that a to the second power, we do not need to put a 1 there. Now 9 divided by 3 is 3. And a squared divided by a is a. B to the third divided by b squared is b. C squared divided by c is c. Plus 15 divided by 3 is 3. A divided by a, that's completely factored out. B squared divided by b to the fourth, divided by b squared is b squared. And c to the third divided by c is c squared. And if you were to distribute 3ab squared c through this trinomial, you would be back at the original term. So, good job. I hope you did well. Make sure to come for extra help if you need it. So let's go back to our exit ticket. When an expression cannot be factored further, it is prime. So occasionally you will get expressions that you cannot factor, and those are prime expressions. I do have a little If you finished early or just later today and you're looking for something to do, I have a little extra activity for you. I have a mindful art mandala activity and a sliding puzzle. And your homework for tonight is here. Homework 5, factoring in polynomials, greatest common factor. And then I've included the key for last night's homework at the end of this document. So great job on all of your hard work. I'm proud of what you're doing. I hope that factoring comes easy for you. And remember, as always, practice, practice, practice means you'll be great.